not recording audio. 1, 2, 3. Never mind. Let's see if it's doing it. I don't know if it's doing it or not. 1, 2, 3. Yeah, it's recording. It's recording. All right. I'll get started here. Thanks, Julie, for stopping up for our observation. And I see you have your pre-observation information here. And would you mind telling me what you're going to be doing for your lesson? And this is for Wednesday, I understand.
Wednesday, 7th hour, yes.
Okay.
We just started our geometry unit, so we're going to design a garden, and they have to figure out the area and perimeter of their garden.
So they're doing geometry.
Yep. And they have a couple stipulations on the size of each section of their garden. Like it has to be a square for one and a rectangle and double the area. And then they have to figure out how much wood to put around the outside.
Okay.
And the next step would be to do soil on the inside and plants, but I don't know. We won't get that far in this lesson, but eventually we might. So.
All right. So first of all, what are the skills that they need to learn or know?
Perimeter and area, and we're doing that today and tomorrow.
So they'll be applying that.
Yeah, they should know area and perimeter of a rectangle, which is what these will be, but it's an application of it, yeah.
Okay, application. And so this is kind of real world, because people are going to do gardens and so on. How can the kids look at this and decide that it's real to them? Because you're kind of wanting to set it up in a way that in 21st century learning, we try to make the activity be as real world or as applicable to what their lives are like. So how do you set up the premise of the lesson?
In my launch, I asked them if they have a garden at home, or if they've ever seen one, or if they've ever built anything, even if it wasn't a garden, and what did they have to do to get that started, which would be to make the plans, which is what we're going to do first, draw it out on grid paper, and then have them kind of describe it, what process they did. But that's just hopefully a short little launch, and then I have a PowerPoint that takes them through the steps of it, and it's a scenario. It's like they're working for somebody, and they ask them to build a garden. So hopefully with those two things, it kind of becomes real life. I actually got it off of a 6th grade performance task website, so it's one that should be right for this grade level.
The math and the skills that are expected are certainly at that level. Now, when you're looking at the students, what would you anticipate their chances or their likelihood of being successful? And if we look at kind of predict what the outcome of this lesson might be, how successful do you think the students will be at performing the task that you want them to do?
Well, I did this, but I did it with my honors kids, and they didn't run into a problem designing it based on a square and a rectangle. But then the wood did a little bit, because do they use the leftover pieces because the board's so long, or do they not? So I anticipated that, but since this is a COTAL CLAT, and there are 9 kids that are special ed and a couple 504, I think I'm going to have, I do have little baggies of the cubes too, so that they could help figure out what size it can be, because I think they might even struggle with what should I do for the dimensions that would make it a square. So I have that for them to start with.
So if you have some kids that may not be able to consider, like, what does, let's say 15-foot square.
Yeah.
What does that look like to them? Are there ways that, or whatever size you want it to be, are there ways for those kids that you could find so that are not exceptionally difficult, but still be able for them to figure it out or visualize it? I've got a couple thoughts in your classroom. All of the tiles are 1 foot by 1 foot. So you could say, well, make your garden 8 foot, and then use desks or do you have the tables or the desks?
I have the desk, yeah.
Oh, I wish it was tables. Well, then maybe they could use tape or some type of material to form the sides.
Right.
And then they might be able to get that. Because I think
Right.
that would be very helpful to them to actually do
Do
it
that.
to at least a size that's bigger than what's on a piece of paper.
Right.
So you might want to consider that.
Yeah, and a sample of a smaller one, because
Mhm.
the square footage has to be between 26 and 50. So if they use
Okay.
whole numbers, there aren't very many squares between that.
No,
So
no.
6 or 7. But some of the kids in honors did like 6.5 times 6.5.
Mhm.
I don't anticipate they'll do that, but I could start with a smaller example too and say,
Well-
if you built one that was,
Sure. I mean,
You know.
I think the fact that if a few kids, maybe it'd be the ones that are in working with the co-teacher, you could have them just mark it
Yeah.
out on the floor, even with masking tape or something. Because there's, like you said, 7 or 8 of those kids. They could get the idea of it, and then they could also find a way to, like you said, what do you do with the extra foot of wood? You know,
Yeah.
if you cut it off here and you've got this extra wood, how can you economically make the perimeter of
Yeah.
the garden?
the actual lesson lets them use all the 1 or 2 foot pieces, but
Mhm.
when I explained it, I'm like, that's going to end up costing you more because you're going to have to connect those along the
Mhm.
way too. But
Well,
they
yeah,
they just did it as the full area divided by
Sure.
the board. that
Well,
you
there's
have,
certainly, a point at which it doesn't pay to
right.
put a 6-inch filler in, but
Yeah.
there would be some decisions, but that's good decision-making
Yeah.
or problem-solving,
Yeah.
because they should think a little bit about the practicality as
Right.
well as the cost. If you put
Right.
all new wood in, then you're gonna spend more,
Yeah.
and I don't know if they would get that or not, so that might be something to try.
Yeah.
Um,
Also, too, I have it to the point of starting on hopefully finishing how much wood they need, but with
Mhm.
that class, I never know, so it might be where they design their garden
Sure.
and started on how much wood they need.
Yeah.
I'm not real sure how long it's gonna take them. I imagine half the kids will do all right and they'll be
Mhm.
done faster,
Yeah.
but like you said, with the co-taught, I'm not sure.
Now,
So-
if you have kids that are getting done, and they've done a satisfactory work, then could they not help some of the other slower kids, or have kids that are having a little trouble?
Yeah.
They might appreciate that.
Yeah.
It might be of help to them. How much of the time will they be up out of their seats, do you think? Will this be pretty much a seated activity?
Well, once they go to where their partners are, it'll probably be a seated activity
Okay.
unless they need to use the floor, like you
Mhm.
said, or cubes to figure out their squares. But
Okay.
otherwise, I think they'll probably be
Sure.
seated.
And you do have some graph paper or grid
Yeah.
paper for them to utilize,
Yeah.
all right?
And I made a table of what they should put in there. They're going to do it in their interactive notebook, but I printed off a table for
Okay.
them to put their dimensions and their
All right.
area and the amount of wood.
Oh, okay.
Oh, I see the wrong one on here.
Oh,
Nope.
that's all right.
Yep. Maybe you don't have it.
Oh, okay, well, I'll have that on
Yeah,
Wednesday.
there'll be a table for them.
So the prediction is that they should be able to do that. Now, once they've done the rectangle, do they know anything about triangles or anything like that?
No, I've been asking today, and most of them don't know how to find the area of triangles at all. Although one that we're doing today is just with a right triangle, because then they see
Mhm.
right away it's half of it. But
Yeah, I would say that in itself would be a good exploration, or a chance for them to discover, what if we made it a triangular garden, and you could have out of a square, so you'd have an isosceles triangle, right triangle, or you could have a scalene triangle with sides all different lengths using a rectangle. That I think would be interesting for them to get that. Now, will they get the relationship that it's half of the base times the height?
well, and on grid paper, even if there's an activity I'm going to do Thursday
Mhm.
too. But if they have the grid paper, like you said, that has their rectangle, if you divide it up into whatever
Yeah.
size triangles, I mean, it hopefully would visualize and make sense to them that you just cut it up, but it's still the same area that you have there.
Mhm.
But how do you figure out the pieces of all that?
Yeah, and they need to work together to come up with that. Hopefully, they'll come up with that. Now, if there's time, I would pursue that a little bit.
Yeah, I might do that with that upper group. I gave them, I have some sheets ready for if they do get finished that has special polygons where they can decompose them, and that would be one.
Sure.
They'd have to maybe make a triangle out of it too.
Okay.
Take it apart to see.
What
but-
types of, as they're working, what do you anticipate what you'll be doing in the classroom? They're at their tables or they're on the floor, but they're basically now working on their problem. What's your role at that point?
Well, we're gonna go so far and then stop. So first we're gonna do the square,
Okay?
stop them, and then the rectangle has to be twice the area.
All
So
right.
after I have everybody share what they got for their their square, then we'll go on to the rectangle, and then I think after, I'll just walk around during those small breaks.
Right.
But then after they have both, then I'll have to explain the wood part to them. So they won't get the
Sure.
whole thing, they'll get it in pieces. So I
So-
see myself teaching and then going around and checking on groups.
Right. Will you have them, okay, one way to make the area of the rectangle twice that of the square shape, of course, is just to take the square and put a copy of it right above it. You have that square and that square. Now you've got a rectangle and it's twice.
Right.
So that's probably what they'll do first, because that's simple and obvious. Can they make a different sized rectangle, but still have it twice the area?
Mm-hmm.
And that would be more challenging to some kids, so you might want to challenge them that way.
Yeah, if they get done early. It was neat to see in honors when we did that, they had similar squares, but everybody had almost a different
Oh, they did?
rectangle. So it
Okay.
was,
And how did they know it was twice the volume, or twice the area? Just by using the base height?
yeah,
Oh.
so if it was like they're 6 by 6, 36, they just did 72, and those kids knew
So they
factors,
factor out 72.
factors to equal 72, yeah.
Well, that's interesting, because then you have factoring. Kids would have to relate that concept to a geometrical problem, which typically doesn't happen.
No,
That would be a very useful
yeah, we,
way to show them that, hey, this stuff that we call factoring
yeah.
has application, because they think it
Right.
ever will.
Yeah, we did, last year we did that, we'd give them like 24 cubes and ask them to make as many dimensions, and then we looked at the dimensions to see that
Came up
those
with-
end up being factor pairs.
There you go.
So-
Well, that would be great.
Yeah.
So
Probably
you're gonna
do
need,
tomorrow.
so you'll have the materials that they need, primarily paper and rulers and
Yeah,
so forth. Okay, now, when they get done, how do they get checked? I mean, do you want them just to turn in their work? Do you want them to share it with someone else?
they have it in their notebook, so at the end, we usually just share things that we've done in our notebook. So a lot of times it ends up being
Will that
the
be
next
during
day.
the next day?
We
Okay.
reflect and we look at it, but in this one, we'll be sharing and reflecting at least their rectangles, their squares, but I don't think we'll get as far as getting the wood done. So I think if some groups do, then they'll either help or they'll do a challenging activity, but I think the reflection on the wood will probably be for the
Yeah.
next day.
Yeah, I imagine so. Okay. And then for your assessment of their work, what will that be? Will you just listen to their presentations or what?
Yeah, look at their work that they have in their interactive notebook, what they came up with, and if they were able to double that area. And I like to, a lot of it's informal assessment because it's just when I talk to them.
Sure.
But I also have a formative assessment that I'll probably end up giving them again the next day, so I imagine we'll reflect over how you came up with the area perimeter and how did you decide that actually the wood was perimeter and not area, because they had been working with area to make them.
Right.
And then give them the formative assessment as to real world applications
Okay.
and see if they know how to do those.
because I used to teach math, I always taught perimeter. I probably shared this with you before, but I always use the word rim as a way for them to remember what the main definition of perimeter is.
I just did that with them before I came
up
up
here.
here.
Good. They'll remember that.
Yeah.
That was good.
Yeah.
Okay. Well, so then we'll look at the success. Now, if they are successful, where do you want to head with, assuming they are, where do you want to head with your next set of lessons that follow? You'll have, they will have learned a little bit about area and perimeter.
Mm-hmm.
What would be your next area too?
Then we'll do volume.
Volume, okay.
So, but I think probably on Thursday yet, I'll make sure that they know area and perimeter.
Mm-hmm.
I can't believe that they really just have to know it of rectangles and maybe triangles, but not
other shapes?
Not really other shapes or like parallelograms, trapezoids.
Yeah.
Not too much of that. So we'll probably just hit those two, and then I like the idea of like even dividing the garden that you have there,
Mm-hmm.
using that part to look at triangles. But then they need to do volume yet, of just a rectangular prism too. So.
Okay. Yeah. Will you have any, and this is almost, in my estimation, becomes abstract learning, and for some sixth graders it might be a little bit beyond them, where they have to look at various, typically they're squared-like shapes, but the perimeter is not a perfect square. There's indentations, there's, it's a very complex shape, and if they look at it long enough, they can analyze it and actually figure out the area, because it's symmetrical and things like that. Do they do any of that where they have to kind of apply for more complex shapes, the concepts of base and height and so on?
Not too much. I did with the honors,
Did you do
but
that with the honors?
and sometimes some of the kids in the hour before that,
Mm-hmm.
I tend to teach them
Well,
a little bit more.
that might be something that is beyond them, because I know we also use it in 8th grade, and it's challenging for them too, so just a thought. Okay, so then, what will be your evidence that the students are finished, they've gotten the understanding, and it's time to basically move on? What will be that evidence?
Their work in their book, but also their explanation that they can give to how they came up with their area of the square and the rectangle, and how they decided to get the wood, you know, that was perimeter. The formative assessment that I'll give, and then I have task cards for the next day too that have story problems on it with area and perimeter, and so they're more mixed up, so they'll have to decide which one. And some kids can keep working on those too. And if I need to help some of the other ones, but in the co-taught, probably Krista will be able to go over it with them. She's teaching IDM or ELT now too.
Oh, good.
With some math kids, so.
Well, that would be very
That's
helpful.
Yeah.
Okay. Are there any kids that I should keep an eye out for, or that you've had concerns about, or?
Can I name the person?
Yeah, because this is not going to go anywhere.
Bradley, he's a 504 kid.
Okay, Bradley, yeah.
And we're having a meeting again on Thursday with them.
Okay.
He wasn't a self-starter at the beginning of the year, and now it's almost the opposite. He'll do it, but he just rushes through it.
Oh, I see.
So even if you try to slow him down, and then his grade for math has dropped to an F, but he just got a good grade on a quiz. One, because he started the reading program, Study Aisle or whatever that is. So otherwise, I had him every day, and I was pre-teaching and reteaching, and you could just see the lack of understanding from class from not having him pre-teach. So Matt said I could have him every other day.
Okay, well,
But he's kind of one to watch, because he's, I don't know, he either sits there or he rushes through it all, but I have to pick a partner for him. It's pretty good.
Okay, so the lesson will be what time on Wednesday? It'll be about 1:10?
7th hour, yeah, about 1:10.
Okay. And we'll see how it goes
Okay.
at that point. But I think
Thanks.
it's a good lesson. I like
Yeah,
what you're going to be doing.
The kids had a lot of fun with it, but
and,
I don't know.
it'll be good.
I
Well,
also
thank
found
you.
another, thank you.
Oh, go ahead.
Or you can turn it off if you want. There's nothing to do with it. But,
All right, we'll switch this off here.
I found one on like Illustrative Math or something. Seems like it's like an old school site, but they took half the class made cylinders, and the other half in my honors made prisms, rectangular prism, and they used the same sheet of paper, so they made either a tall, skinny one or a fat one. And then if they made these two, they put the skinny one inside this one, and we filled it up with the skinnier one with popcorn. They made a prediction as if the volume would be the same.
Yeah.
They thought the taller one would, almost all of them, no matter what, thought the taller one would be a bigger volume. So they filled that, and then they just pulled it out, and they were amazed to see that it went down to like, it was like, mathematically, it was about a third.
What I like
that was
about
kind of
that,
interesting to
what I
see.
like about that, that reminds me of a story. My dad taught me that concept years and years, I think it was years ago. We were at a baseball game in my little softball game in my town, Stanhope, and we were sitting there, and he just asked me the question, why do you suppose the popcorn box is shaped the way it is? And I said, I don't know. And he says, because it looks like you're getting a lot of popcorn, but you're not. He says, here, I'll show you. And he took the popcorn box and just rounded the sides of it, just kind of squeezed it and rounded it, and the level of popcorn went down because it was a bigger volume. And that impressed me. I thought, I didn't think my dad was that smart.
You got all your math from him.
Right, maybe so. But that was a very good example of surface area compared to the volume of something. And it was so simple and elegant the way you did that. But this is what you're doing.
Yeah, they were just amazed. They were like, oh, like not even close.
There's I think there's a video on TV, on the computers now, about this beer company that was selling beer in tall glasses and more round or squat glasses. And the taller glasses, they were charging more, and they turned out to be the same volume. So again, same thing.
Yeah, because even the glasses we have at home, the normal drinking ones, and then the ones that are supposed to be for juice, but it's bigger diameter. So my mom was always like, oh, I take the short one, you know, and I don't want as much. And I'm like, so one time I just poured them in. I'm like, they're the same. It's just, I don't know why they do that either, but it's pretty much the same.
That goes
volume.
back to child development, back in college years, and Piaget and all of that, where you would conservation of volume and so on. And I was doing that with my little nephew and niece one time. I was saying, which is bigger, the tall glass or the flat glass or flat whatever. And my sister got really mad at me. Don't experiment with my kids. Oh well, that's enough of that. We'll see you on Wednesday.
Yeah.
All right.
And David's going to be there?
Hopefully. We'll see how it works out.
And videotape?
Well, we'll do that too.
All right, thank you.
Yep.